Hello, everybody, and welcome back to Math 100. Today, we are to start Chapter 5, the chapter on statistics. Okay, I don't have to tell you that statistics is all around us, all right? And basically, pretty much all the policy decisions out there are made based on figures, numbers, statistics, and statistical analysis, all right? We are going to look at this carefully. Chapter 5 is, again, one of the most important topics that we will need to learn because statistics basically controls the world. All right, so we'll start with the basics of statistics in this section, which is section 5.1. Ready? Let's get started. Okay, so we have section 5.1, and the title of this section is Basics of Statistics. All right, so we have 5 sections in this chapter, and today we will just be talking about the fundamental aspects of what statistics is and what kind of data we have and so on. All right, so the main question here is this: how can we determine if a statistical study is reliable? And statistical study sounds fancy, but it's really like most of the things that you read in the newspaper. Like we talk about the COVID-19 pandemic, how many people are getting sick, are the situations getting better, how many people are being vaccinated. Those are all statistical studies in a sense. All right, we'll talk about different types of statistical studies in the next section, but right now let's go into the basic terminology. All right, so the first word I'm going to tell you is, not surprisingly, the word statistics. And it's a little tricky because it sounds like a plural word, okay? And it is in some context, but the first number, or the first term I'm going to give you is this word statistics, used as a singular noun, okay? So even though it ends with an S, right now I am treating it like a singular word, statistics, and it is the branch of science, or branch of it's a discipline, an academic discipline, if you will, a science of collecting, organizing, and interpreting data in order to draw conclusion. Right, so that area is called statistics, just like physics and mathematics and other science names that ends with an S. Okay, we treat this as a singular noun. All right, now the next word is, and this is also a little tricky, the word population. And the word population often means a number of people or a number of species or something, right? But in this context, it is not a number. Okay, so make sure you understand that. When we talk about a population in statistics, it is the set of things, okay, the entire set of things or people being studied in a statistical study. All right, so it is often too big. Okay, maybe the population would be like all the people in the United States, because maybe a study is being conducted to understand something about the people who live in America. So in that context, the population would be all the people in or living in America, not the number of those people. Okay, you get that? Population in statistics is a set being studied. Now, because the population, or because a population is usually way too big, what we, or statisticians or data scientists, do is to look at a part of it, and that part is called a sample. Okay, so a sample, what is a sample? A sample is a subset. Okay, it's a part of the population. So a subset from which the data is collected. It's a subset of the population being studied. And of course, the way you pick the sample is extremely important. What we want to do is to make sure that we have as little bias as possible. Note, I didn't say it should be completely free of bias, because you really can't do that, or it is extremely difficult. My belief is that you can never get rid of all of the bias, okay? Because it is very difficult, right? We'll talk about that later. Okay, a true value. Let's say you're trying to find the average height of all Americans or something, right? In that case, the population would be all Americans, and the sample would be, some subset of people that you will collect the data from. Anyway, the true value that you're looking for is called, okay, let me see, a true value about the population. In this case, maybe the true average height of all Americans. That's really hard to get, right? Because, I mean, how do you really figure out the true value, the true average value of all American people's heights? Okay, so, but anyway, that true value that you are looking for is called a parameter. The parameter is something that you will probably never find. Okay, I mean, I'm convinced that you can never ever find the true average height of all Americans. There's a reason for it, right? Because it's impossible to measure everybody's height at the same time all over the country. And even if you could do that, it'll change constantly because people grow and so on, right? So we can hardly ever know what this parameter is. So what we do is we come up with an estimate. Okay, how do you find this estimate? Well, we take a sample and we measure their height, for instance, right? And we take the average. But that's not a true parameter, right? So that parameter is estimated by you ready for this? The statistic. This time, the S at the end of the word is missing. And so this is a statistics. Now, it's a statistic. And we treat this as a singular word. The plural of this word is statistics. Okay, if you have more than one estimate, it's called those are called statistics. But one of these is called a statistic. Get that? So a statistic is a numerical value calculated from that raw data in order to estimate the parameter, which probably will never be discovered perfectly. All right, so here's a diagram. Let me go ahead and draw this diagram for you. I think it's very enlightening to understand this diagram or to draw this diagram. Right. So first we have the population. Okay, and I'll give you an example in just a second. Right. The population is usually, it's a set of people or insects or whatever. Okay, and we want to know something about this population. That's what a statistical study is all about. Unfortunately, the population is way too big, okay? And so what we do is we take a sample, and this process is called sampling, not surprisingly. Right? And when you take the sampling, the thing that the subset of the population that you really study is called a sample, right? Now, you don't want this to be too small, but it's impossible to have all of the population being studied in most of the time. So you take a sample, we hope it's unbiased or as unbiased as possible. And we study this sample and we collect data from it and we analyze the data. And from the data, we calculate a statistic. Okay, now you may be interested in a couple or 3 or 4 or more of the data. And you may be looking for instance, an average height and average weight and average body mass index or something. So there may be more numbers than just one number that you're after. And so those are called statistics. Okay, each one is called a statistic. So this is the collecting and analyzing data. And these statistics are, if the sample is unbiased, supposed to reflect and help us to estimate the real values, parameter or parameters. Okay, so this is the estimating part. And hopefully, if this is done correctly, those statistics will truly reflect or accurately reflect those parameters. All right, and then of course the parameters are belong to the population. All right, so this is the concluding part. So keep this in mind. I think this is a good way to understand what happens in a statistical study when you take a statistical study, take measurements, or when you do analysis concerning the population. But you don't study the entire population because the population is usually or often too big, and so you take a sample. And this sampling is something that we will be looking at in just a second. All right, let me give you an example. So here is an example. Let's see, can you see this? What's the true average height of all Americans? Okay, we don't know that. And in fact, you will never know this, okay, for the reasons I already gave you. So the true average height of all Americans, the true average height is the parameter, right? We will never know this, unfortunately. So what do we do? Okay, like I said, we will take a representative sample and find their average. Okay, so let's say you pick 5,000 people from all over the country, including male and female subjects, and whatever. And so we take a representative, unbiased sample and find their average, and the average you find is the statistic. Okay, and this is in this case a sample mean because you are looking for an average. Okay, so you take the sample mean, and that is called the statistic in this case. And then we use that statistic. So in this case, we use the average height of the people that you have measured, the sample. And so you use that statistic to estimate the parameter, okay, which is a true value, which you'll never know, but you can estimate, right? I'm telling you, the truth is hard to find. And then sometimes the truth is impossible to find. Maybe in most cases, the truth is impossible to find. So statistics is really this effort by mankind to estimate as accurately as possible that which is unknown, which is unknowable, right? But we do a pretty good job by studying a representative sample, right, in order to estimate true values. All right, so you have a couple of different types of data. One is called quantitative, and this is the numerical data. Okay, so heights, weights, ages, and so on. So this is where arithmetic calculations make sense. Sorry about that. I'm going to make this into a one-line statement here. So if the data you're collecting is numerical, meaning those are numbers, where arithmetic calculations make sense, those are quantitative data. Qualitative data, sometimes called qualitative or categorical data, those are non-numerical, okay, and those are have to do with attributes. So attributive. So for instance, if you take a survey and say, hey, what color are your eyes, or what color is your favorite? What is your occupation? See, these are not going to get numerical answers, and so those are qualitative data. Right? Let me give you examples of each. So what kind of data would be quantitative? Can you think of any quantitative data? I gave you weights. I'll give you the height. Price of something, of course, is quantitative. Okay. Basically, the way to think about this is this: if you can take a whole bunch of these data and take the average, okay, and if the average makes sense, that would be quantitative type of data. Okay. You see, colors and occupations, you can't take the average, right? So that's why those are not quantitative. All right, so quantitative, you have weights, height, price, income, household income, price of homes, number of cars belonging to each household. That would be a quantitative data. Temperature, because you can take the average temperature, for instance. All right, so you have many different types of quantitative data. All right, how about qualitative data? Okay, I have already mentioned, for instance, the color of one's eyes, or color of one's cars, job, occupation. If you ask people, what is your favorite food? Okay, you can't take the average of, a Thai food and Latino food or whatever, right? So you can't consider these quantitative. Flavors, sport. What is your favorite sport? So well, I have football and basketball. So let's add them up and divide them by 2. No, you can't take the average of 2 sports. All right, so these are the categorical or qualitative data. These, by the way, if you study if you take our 5-unit statistics course, you will be studying these at the beginning of the semester as well. All right, let me give you something else here too. I'm going to give you a little warning. All right, zip code. What about the zip code? All right. Zip code is numerical, right? I mean, after all, that consists of 5 digits. It's a 5-digit number. So is that quantitative? And the answer is here. Although it is numerical, it is considered qualitative, categorical data. Why is that? Okay, because it doesn't make sense to see zip code doesn't represent any quantity, like age or height or price. Okay, because a zip code is basically for the identification purposes, right? You can't, for instance, add them up together to make sense. You can't take the average of this. Okay? So, like the average doesn't make sense. Okay, so you get your zip code and your friend's zip code, you add them up and divide it by 2. What does it mean? It's not going to mean anything. So a zip code or the phone number, those are considered qualitative because the arithmetic calculations will not make sense. Okay, so I hope this is clear. Right, so zip code is qualitative. Even though they are numerical, it does not make sense to average them, add them, and so on. It's only for identification purposes. All right, so now let's go into the methods of sampling. Maybe this is a good point to pause, and we will go into part 2 of videos in the second page.